Okay, and polygons are the enclosed figures that fit kind of what we assume are the lines, the straight lines. And so if you look at these examples of polygons and non-polygons, you can kind of identify the distinguishing characteristics. I'm going to place a couple other things that are not considered polygons up here. Okay, so that element or that illustration is also not considered a polygon. Okay, and then that element, again, not considered a polygon. Okay, so let me talk about some of the kind of defining characteristics of polygons. Okay, first, as with all of these enclosed figures that we're talking about here, it's a coplanar figure. And so this definition, or these two terms, kind of indicate two things. One, it indicates that it's two-dimensional, it's coplanar. And then the fact that it's called a figure includes what the figure defining characteristic is, which means it encloses a space. And so in this top group right here, none of these enclose a space. And so that's why those aren't considered polygons. And so a polygon has to be a coplanar figure. It has to be formed with line segments. Okay. So all the other ones are out, well, so except for this one, are out because they have curved sides. But in a polygon, all the sides have to be straight line segments. And then the last kind of characteristic that will eliminate this final counterexample is the sides will only intersect at the endpoints. And so that eliminates this one, because here, as we connect these two endpoints, it passes through the middle or somewhere in between other sides. And so that one doesn't have the intersection only at endpoints. And so those are the defining characteristics of a polygon. And most of what you guys are familiar with as far as figures go are figures with straight lines, which are the polygons. All right. Let's look at just how polygons are named and manipulated. Right, when you name a polygon, so as with or anytime you're naming polygon, you're going to identify each vertex with a letter. So the vertex, the plural is vertices, and the singular is vertex. And the vertex is just the intersection of endpoints, or the intersection of segments. Okay, so the vertices are labeled with points, and the number of sides and the number of vertices are exactly the same. So if you have, in this case, 1, 2, 3, 4, 5 points, this is also going to be a polygon with 5 sides. And when you name a polygon, you name it just by its vertices, and you can start at any point. You can move either clockwise or counterclockwise, but you have to move in consecutive vertices. You can't skip around. And so if we wanted to name this polygon, we can name it PQRST. We moved in counterclockwise rotation, but we moved from consecutive vertex to consecutive vertex. We didn't jump around and skip over. All right, when you're dealing with consecutive sides, and so consecutive, or first of all, if you connect consecutive vertices in a polygon, you form sides of the figure. And so consecutive vertices form sides of the polygon. Non-consecutive vertices, so if we were to connect non-consecutive vertices, So if we wanted to identify segments connecting non-consecutive vertices, so P to R, P to S, S to Q, R to T, Q to T. So those would be non-connecting or segments that connect non-consecutive vertices. Those are called diagonals. Okay, so connecting consecutive vertices are the sides, connecting non-consecutive vertices are diagonals. Okay. All right, questions about that? Yeah. Well, so in this, as long as they're not consecutive. So Q and T would be consecutive to P, so those would be the ones not counted. But if you had, let's say, so if you add 6 sides, now there's going to be 3 coming out from each one. So you don't always think about it as opposites. They look like opposites because these are kind of symmetrical figures, but they won't even always be symmetrical figures.